With the surge in popularity of computer and mobile-based sound systems, USB speakers are enjoying newfound attention. Despite their limited power handling and dynamic range, along with budget constraints, their compact size and simplicity outshine traditional stereo setups in some applications. While not as straightforward as Bluetooth speakers that combine two channels into one unit, USB speakers are portable and free from cable tangles and external parts. Moreover, there's a simple way to enhance the sound quality of these speakers without adding cumbersome components or breaking the bank. In this video, you'll discover how to elevate the audio performance of these convenient USB speakers with minimal modifications and marginal costs. At big box stores like Walmart, one of the cheapest speaker options available off the shelf is the ONN USB powered stereo speakers. Priced at around $10, they undercut even the most affordable USB speakers on Amazon today. The manufacturer provides the following specs: 2.5-inch copper-tinted drivers, 1.5 watt RMS output / 3 watt peak output per channel, integrated volume control, 3.5 mm AUX jack, attached speaker wire, 3.6 feet, attached 3.5 mm AUX cable, 5 feet, attached USB power cable, 5 feet. With a power rating of 1.5 watt RMS and using 5 volts USB power, these speakers are understandably limited in their output capability. But are they practically usable even for casual computer use? Let's investigate. Purchasing a set of ONN USB speakers from Walmart for $12.99 plus tax, my first impression upon unboxing was that they were larger than expected. While the speaker enclosures were small, the actual speaker units were larger than many competitors in this category. Connecting them to a laptop and playing music, my initial reaction was somewhat disappointing. The lack of bass was anticipated given their size, but what stood out was how easily they distorted even at moderate volumes. Given the 1.5 watt per channel rating, this distortion wasn't surprising, but it was still disheartening. Aside from the scratchy distortion, the volume ceiling before reaching distortion was quite low. This meant compromising on volume, rendering the speakers practically useless for anything beyond close proximity listening. In theory, the power limitation could stem from two factors: the capacity of the internal amplifier and the speaker's power handling capabilities. The internal amplifier is powered by a 5 volts USB DC power source, which is divided to plus or minus 2.5 volts DC to handle the sinusoidal waveform in the sound signal. Consequently, the supply voltage for the internal amplifier cannot exceed 2.5 volts maximum on both the positive and negative half waves unless voltage multiplication technology is employed. Without further ado, I opened the speaker case to examine the internal amplifier's construction. The amplifier circuit revolves around a single Class D chip, specifically the NS4203. Consulting the datasheet of this amplifier chip reveals its specifications. It accepts supply voltages ranging from 1.8 to 6 volts, while the proper working voltage has a slightly narrower range of 3.5 to 5.25 volts. When operating with an 8 ohm load, the total harmonic distortion combined with noise hits a minimum value of 0.04% around an output power of 0.2 watt with a 2.5 volts supply voltage. Beyond this output power, distortion rapidly escalates, easily exceeding 1%. I will consider this turning point of THD plus n equals 0.04% as the practical limit of output power. Increasing the supply voltage to 3.6 volts raises the practical output power limit to around 0.6 watt. At 5 volts supply power, the limit extends to approximately 1 watt. With a 4 ohm load, the output power limit slightly increases. At 2.5 volts supply power, it sits around 0.6 watt, reaching approximately 1 watt with 3.6 volts, and climbing to around 2 watts with a 5 volts supply. Regardless of the supply power applied, the output power limit remains quite restricted. While 1 watt of power can generate sufficient volume when connected to regular speaker units, the 2.5-inch USB speaker units aren't designed to produce such high sound pressure due to their limited surface area, particularly at lower frequencies. When comparing the maximum output as a function of the supply voltage, it becomes obvious that this Class D chip was not engineered to deliver high power within a practical distortion limit. Hence, replacing the internal amplifiers with a proper amplifier board becomes necessary. However, the new board may not fit into the compact speaker enclosure. Thus, the plan involves removing the internal amplifier board and attaching an external amplifier to replace it. Additionally, the 2.5-inch speaker units possess significant limitations in power handling. Originally tailored for the use with USB-powered internal amplifiers, these units boast relatively high sensitivity, allowing the small amplifier power to produce the loudest sound possible, particularly in the bass range. To achieve adequate volume, the mass of the moving part, or the diaphragm, was required to be reduced in the original design. This must have necessitated softening the support structures such as the surround and the spider to maintain a low resonant frequency. However, this compromise leads to low support strength, making the speaker drivers susceptible to distortion as the voice coil may rub against the magnet pole when moving in the gap. Consequently, the speaker drivers are prone to distortion and have a capped maximum power handling. The markings on the back of this particular speaker's magnet indicate a 3 ohm impedance and a purported power handling capacity of up to 3 watts. However, it's reasonable to assume that even this 3 watts rating is exaggerated, with a maximum power handling likely below 2 watts. This inherent limitation of low-power speakers is challenging to overcome without replacing the entire speaker units, which exceeds the practicality of budget for enhancing these inexpensive USB-powered speakers. Therefore, in this modification, I'll adhere to the stock drivers and aim to extract the maximum capability from the factory parts. The modification process proceeded smoothly. Initially, I removed the internal amplifier board from the right speaker, a task accomplished with ease by removing a few screws and simple desoldering. Once the wires detached, the entire amplifier board was removed. The left speaker, being passive, required minimal effort to modify, necessitating only the removal of the old wires from the speaker terminal. Next, I utilized 18-gauge speaker wire, soldering it directly to the terminals of both left and right speaker units. However, I encountered a slight issue with the exit hole for the speaker cable on the left unit, which was too small for the 18-gauge wire. To address this, I enlarged the hole using soldering iron, melting it to increase its size. I then ran the speaker wires through the holes, securing them by making a knot to act as a stop before sealing the gaps around the holes with a glue gun. Finally, I used solder to reinforce the ends of the speaker wires, ensuring their solidity. To enhance the acoustics, I filled the empty voids of the speaker enclosures with polyfill, serving as sound absorption material. With the speaker conversion complete, I utilized an external Class D amplifier based on the TPA3116D2 chip to power the speakers. This external amplifier, housed in a miniature casing, boasts an integrated DAC circuit, a Bluetooth receiver, as well as a traditional 3.5mm analog input. This versatility allows for seamless connectivity to various devices such as computers, mobile phones, and traditional analog devices with headphone outputs. While the power handling of these speakers remains limited, it's essential to use a proper power supply with adequate output current. Given the 3 ohm impedance of the speaker drivers, the amplifier requires a reliable power supply source capable of meeting their demands. The outcome of the modification proved remarkably successful, especially considering the scratchy and distorted sound output from the factory speakers. While there remains a trace of distortion and certain limitations, the improvement over the stock speakers is substantial. Now, the speakers are suitable for daily entertainment in various scenarios, albeit not for demanding hi-fi applications. The journey to enhance the sound quality of the budget-friendly ONN USB-powered stereo speakers from Walmart has been an insightful and rewarding experience. By delving into the technical specifications of the internal amplifier and speaker units, we gained a deeper understanding of their limitations and potential for improvement. Through simple modification steps, including the removal of the internal amplifier board, soldering of speaker wires, and tuning of speaker enclosure acoustics with polyfill, we successfully transformed the speakers into passive units ready for connection to an external amplifier. The integration of an external Class D amplifier, featuring functionalities such as an integrated DAC and Bluetooth receiver, vastly expanded the versatility of these speakers, allowing seamless connectivity to a myriad of devices. While acknowledging the inherent limitations of the speakers, notably their restricted power handling and susceptibility to distortion, we optimized their performance within the constraints of the original components. In essence, this modification project proves that creativity and resourcefulness can enhance the audio experience of budget USB-powered speakers, showcasing how minimal modifications can yield significant improvements in sound quality and versatility.